Okay, the session is being recorded. This session is about Section 2 of Chapter 16, Net Present Value. We have some assumptions about the timing of inflows and outlays. Inflows means money come in. Outlays means money come out, is the expenses. The first principle. All cash inflows or benefits are assumed to be received at the end of a period. So when you do the questions from my lab or from the textbook, if the question didn't tell you it is end or began, the principle is here. It is stated in the PowerPoint. All cash inflows are at the end, okay, unless it is stated otherwise. The second principle, all cash outlays or costs are assumed to be made at the beginning. Okay, those are the assumptions. You don't read PowerPoint or you don't read textbook, you missed out those two assumptions. That's why we need both PowerPoint and examples exercise. So now we take a look at an example. A feasibility study concerning a contemplated venture yielded the following estimates. Initial cost outlay 1,300,000. Further outlays in years 2 to 5, 225,000 per year. Each year you have to pay this money from year 2 to year 5. Residual value after 20 years, 625,000. So those are the cost. The benefits are the returns. From year 5 to year 10, 600,000 per year. And from year 11 to year 20, 500,000 per year. Those are the benefits. The question is, should the venture be undertaken if the required return on investment is 15%? That is the question. So those items are the cost. And the net return are the benefits. So what you are going to do, you are going to compare cost with benefits at the same time. For example, at today, as of today. So you are going to calculate the present value of the cost. You are going to calculate the present value of the benefits. Then you compare cost with the benefit. If benefit greater than the cost, you undertake the venture. If the benefit smaller than the cost, you reject the venture. Okay. If the benefit equal to cost, this is arbitrary. You can accept or you can reject based on other factors. Normally, you would have either greater or smaller than. Seldom, you would have a benefit equal to cost. So now, we analyze these questions. We are going to calculate first formula method, then I will present calculator method. So we are going to calculate the money in, present value of the money in means the benefit. Money in means benefit. And then we are going to calculate the present value of money out means cost. Okay. What is the benefit? It is stated here. See, benefits from year 5 to year 10, it is 600 per year. So this is an annuity. The question is, what is the present value of this annuity? Another benefit from year 11 to year 20, 500,000 per year annuity. What is the present value of this annuity? So you add two present value of these annuities, you get the benefits. You get the benefits. Okay. Because the benefit start from year 5 to year 10. Okay. From year 5 to year 10. Each year you have 600,000. So step 1, you need to calculate what is the present value at this point of this annuity. And then you need to calculate what is the present value at this point. After you calculate the present value at this point, this value becomes future value comparing to this point today. This is today, our focal point. The present value at year 5 of the annuity becomes the future value of today. Okay, so this value becomes future value reference to today. And now you need to calculate the present value of today. Okay, and this is from year 5 to year 10. And from year 5 to year 10, what is the N, term N? So 5, 6, 7, 8, 9, 10. It is 6. From year 5 to year 10. 5, 6, 7, 8, 9, 10. N equal to 6. And then from 11. From 11, I'll continue use different line. From 11 to 20, there is another annuity. From 11 to 20, N equal to 10. So 11, 12, 13, 14 until 20. It is term N equal to 10. And you need to calculate what is the present value for this annuity. Present value reference to this point at the start of year 11. And this present value becomes future value relative to today. So you need to calculate the annuity, the present value of this annuity represented by the blue line. And this present value becomes future value reference to today. Okay. And you calculated another present value. And then you add these two present value. That is your benefit for today. Benefit. Okay. So I will maybe label the steps. I will use different color to label the steps. Step 1. Calculate the present value of annuity from year 5 to year 10. And step 2. Calculate the present value of the annuity you have just calculated. Step 3. Calculate the present value of annuity from year 11 to year 20. Step 4. Calculate the present value of the annuity reference to today. And then add step 2, the result of step 2 with step 4, you get benefit. Okay. All right. This is now I'm going to do calculator. Then the PowerPoint give you the formula method. Okay. So I'm going to show my calculator. Put it here so that you. So first, I'm going to do step 1. Step 1. What is the present value of annuity from year 5 to year 10? Second, quit. PY equal to 1. Oh, this is the benefits. Remember, the assumption is benefits. You receive benefits at the end. Benefits. So I heard questions. It is, I will tell, good question. The question is, it is begin or it is end? The benefit is at the end. The cost is at the beginning. That's the reason you need a PowerPoint. See this PowerPoint? The benefits at the beginning of the period. The cost is at the beginning. Okay. So go back to this question and pull out my calculator. So we are doing benefit now. So I'm going to set begin mode. Second, quit. Right now, my calculator is begin. I need end. So you do this. Second, begin. Second, set. Second, quit. You have end mode. Okay. I repeat, to change from begin to end, you do second, begin, second, set, second, quit. Now it is end mode. So step 1, what is the present value of annuity from year 5 to year 10? Go to second PY. PY is 1. Enter. CY down arrow. CY is 1. Okay. The return on investment is annual return. CY is 1. Enter. Second, quit. And now enter 600,000 is PMT. Negative PMT. Okay. 15 is IY interest. From year 5 to year 10, N equal to 6. 6 is N. Okay. So we enter the 3 numbers. We need 4 numbers. 0 FV. Final step, compute. Compute PV. So this is my number. I need to store this number because I need to use this number later. See, this number becomes future value. The present value of annuity becomes a future value reference to today. Reference to today. So I'm going to store this number in 1. Okay. At the same time, I'm going to write down this number. This 0.616. So this is step 1 result. Step 1 result. Okay. So now I'm going to do step 2. Step 2 means what is the present value of this number we have just calculated. Okay. So now I'm going to do step 2. In step 2, this value becomes future value. So this one, I will type in FV. This number is FV. Okay, this is my FV, future value. From today to year 5, n equal to 5. This is a regular compound interest problem. 0 is PMT. 15 is IY. Compute PV. So I get this number. That is step 2. Okay. Let me compare the formula method. Looks, I need to double check my settings. Looks like this one. I need to double check my number. I will check the message first. The question is why n is 6. Another question, how did you get the PY and the CY? Good question. 2 questions. Okay. Now I'm going to explain. First question, why n is 6? Remember here said year 5 to year 10. So you have to count year 5. So why is it year 5 to year 10? So year 5, year 6, year 7, year 8, year 9, year 10. How count? 1, 2, 3, 4, 5, 6. Did you get 6? From year 5 to year 10. That is first question. Second question, how do you get PY, NY? Okay. So the net return, you receive this benefit per year. You receive per year means PY equal to 1. This is per year. Per year, that is indicator. PY equal to 1. And how do you get CY equal to 1? The required return on investment is 15%. It didn't say anything. By default, it is annually. Okay, so I answered those two questions. Now I need to double check this number because this number does not agree with the number we get from calculate formula. Okay, so I'm going to double check this number. So I'm going to create second equation. PY is 1, CY is 1. What I'm doing now, I'm double check step 2. Okay, so in step 2, I need to recall this one. This one is my future value, FV, future value. From today to year 5, that is n equal to, let me see the, n equal to, I enter, see, from today until actually year 4, because year 5 counted as annuity here. So from here today to here, n equal to 4. Y4, year 1, year 2, year 3, year 4. Year 5 belong to annuity. Okay, so that's why the reason this number is wrong, because I entered n equal to 5, n equal to 4 would be. So I'm redo this. Future value is this one. Remember the result of annuity from step 1 becomes future value. Okay, so future value equal to this. And now number 4 is term n. See my number 4 here. Number 4 is term n. And then 15 is IY. And then 0 is PMT. Compute PV. So this time is right, this number. Okay. So I'm going to store. I'm going to add negative and store this number in 2, means the result of step 2. At the same time, I'm going to copy this number down here. So this time, this number agree with this one here. See? Agree with this number. I will explain this formula in one sec later. Okay. Now I'm focusing on calculator method. Okay. All right. So I did step 2. Present value of the annuity from year 5 to year 10. Okay. By the same token, by the same procedure, I will do step 3. What is the present value for annuity from year 11 to year 20? Okay. And then step 4. What is the present value? Okay. So in step 3, n equal to 10. From year 11 to year 20, n equal to 10. And also, so let's step by step. Do step 3. See my step 3. What is the present value at this point? Here. So go back. PY1, CY1, correct. Second quit, clear anything. And then 500,000. This number is PMT. 10 is term N. 15 is IY. 0 FV. Compute PV. So I got this number. Okay, PV, the result of step 3. I will store this number in number 3 because this number will become future value reference to today. Okay. At the same time, I also need to copy down this number. Maybe I will do step 3 then copy down later. Maybe copy down before in case I lose this number. So the result of step 3 So this is the result of step 3. Step 4, I need to calculate the present value of this money, the one from step 3. Okay. So to do step 4, this value is future value. This value is future value. 0 is PMT. It is just the normal compound interest. 15 is interest. 10 is term N. Compute present value. So I'm going to store this number in 4. Okay. So at the same time, I'm going to write down this number here. Step 4. I got this number. All right. And the final benefit, you add step 2 with step 4. So let me check my step 4 number with the formula method. It is correct, this number here. Okay. So when you add this number, the benefit is this number here. This is a step 2. This number from step 4. Add step 2 with step 4, you get total benefit. Okay. So step 3, step 2 plus step 4. Okay. That is the calculator method for calculate the benefits. Now, formula method to calculate the benefits. For formula method, you see this blue box here. It is the present value of ordinary simple annuity to end of year 4. So this is actually step 1. The result of step 1. What is the present value of annuity? N equal to 6. Okay. And now times this. That is the step 2. I will write down the formula. In step 1, what I try to do now, I try to write down the formula. Okay. So in step 1, the formula you used is PV equal to PMT times bracket 1 minus 1 plus I raised to power negative n over I. This is step 1. Okay. And step 2, the formula you used is PV equal to FV times 1 plus I raised to power negative n. This is step 2. This FV is the result of step 1 PV. Step 1 PV becomes FV in step 2. See this diagram? See, this is PV. PV becomes FV in step 2. Okay. And then step 3, use exactly the same formula. Step 3, also this formula. Step 4, the same formula, plug in different number. Okay. So this is the benefits. The benefits. I introduced both calculator method and the formula method. Now, let's do the cost. The cost. By the way, this one you have similar questions from MyLab. Actually, most examples presented in the lecture or textbook have similar questions in MyLab. Okay, that's why I strongly suggest you do examples first. Do examples many times until you are very confident and comfortable with each and every example. Then you start doing MyLab, and you are in good shape. So the cost, initial cost, this is already present value. Further outlays, further cost in year 2 to year 5. Year 2 will cost 225,000. Year 3 cost 225,000. Year 4 225,000. Year 5 225,000. So this is an annuity. Okay, and we are going to calculate what is the present value of this annuity. Okay, present value of this annuity. And once we calculate the present value of this annuity, we add this value here. Maybe this is the step 1, today's value. And step 2, calculate the present value of the annuity. Okay. Present value of the annuity. And then you add step 1 with step 2, then minus the residual. Step 3, calculate the present value of this residual value. Step 3, calculate the present residual. And the last step, you use the cost is step 1 plus step 2 minus step 3. That is the cost. That is the plan for how do you figure out the total cost. Do 3 steps. Step 1, initial cost, you do nothing. That is the initial cost. Step 2, you do the present value of annuity from year 2 to year 5. Step 3, you do present value of the residue. And then step 1 plus step 2 minus step 3. That is your total cost. Okay. All right. So let's carry out our plan. First of all, based on calculator and then formula. The PowerPoint give you formula here. Okay. So the PowerPoint, this is step 1. This is step 2, present value of the annuity. This is step 3, present value of the residue. So step 1 plus step 2 minus step 3. So this is formula. So calculator, I'm going to show you calculator. Then we compare formula method. This is the cost. Remember, we need to set see, all cash outlays costs are assumed to be made at the beginning of a period. Beginning of a period. So we need to set up our calculator begin mode. That's why you need a PowerPoint presentation. You need some concept, some principles. So second quit. And again, how do I do the begin? You do this. Second begin. Second set. Second quit. So that your computer has BGN began. Okay. We don't, step 1 is just this number. We do step 2. What is the present value of annuity? Okay. So 225,000. This is a negative PMT. Okay. 4 is N, because year 2, year 3, year 4, year 5. So 4 is N. 15 is IY. 0 FV. Compute PV. So this is the number we get. Okay. So I'm going to store this number in 1. Oh, should it be 2? Doesn't matter. Okay. So this is our step 2, present value of annuity. Step 3, present value of the residue. Present value of the residue. Let me check this number to see. The number does not agree with this one here. I'll double check. Step 2, I will double check the step 2 number, okay? Step 2, we need to calculate annuity for year 2 to year 5. Year 2 to year 5. So I'm going to clear everything, double check PY is 1, CY is 1, and then PMT N is 4. So number 4 is term N, 15 is IY, 225,000, that is PMT. 0 is FV. Compute PV. Compute PV. I get the same number here. I will write down my number and then I'll see. Sometimes I'll double check this. So 738 725 0.65 0.6514. Oops. This is the number I get. Now I will verify the number from the PowerPoint slide. This is the step 2 they get. So I'm going to verify this number using Excel. What equal 225 000 times bracket 1 minus 1.15 raised to power negative 4 closing bracket. This is closing bracket divide 0.15. So this number is correct based on this formula. And then I will use PV. I'll use PV function to verify what the rate is 15% for TNT 225000. Future value type is future value 0, 1. Rich MPL. I have extra bracket. Oops. Undo it. I have extra bracket here. This bracket is alright. Oops.
You do it in end mode, you get it right.
What did you say? Sorry.
I did the step 2 in end mode, and I got the variant that's on the PowerPoint.
Oh, you use the end mode, right? Yeah. Then you get this one.
I get the 642 number in end mode.
Thank you for your observation.
No problem.
All right, but the principal said the cost is at the beginning. So I would suggest we stick with the principle. Okay. So this one should be at if this is this number times so this number, if the difference between begin and end is 1 period of interest. You see, if I use this number times 1.15, I get the number from the calculator. Okay, so I will make a note here. So this one is based on end. The formula is based on the end mode that get this number here. But really, we need the begin mode because this is the cost. Okay, so I'm going to write down a note. We need the begin, BGN, because it is a cost. Okay. when you use begin, so this number has to times 642, 370. This number times the interest 1.15. You get the end, the begin mod. Okay, so this is this number we get 738 725.65. Okay, so you see the discrepancy here. Okay, the principal said the cost will based on begin, but when you did the PowerPoint did calculation, it based on end. That's not right. So we stick with our principle. The cost will start at the beginning mod. Okay, so our calculator is correct. Okay, so step 2. Unless it is specific cost happened at the end, and then the PowerPoint is correct. But it didn't say the cost happened at the end. All right, thank you for your participation, Kaylin. Step 3, we need to calculate the present value of the residue after 20 years. Okay, and this is the calculator method or formula method, step 3. Now we do the calculator, do step 3. Okay. When we do the calculator, this is regular compound interest. So we switch back to the end. By default, it is end. Step 3 is not annuity. Step 3 is a regular compound interest problem. Okay. So double check PY is 1, CY is 1, and then 625,000. That is a future value. Oops, so I did something wrong. Second PY is 1. Down arrow, okay, CY is 1. Second quit. And now 625,000. That is future value. 0 is PMT, or regular compound interest. 15 is IY. 10, no, 20. No. 20 is N. Compute PV. That is the number. Yeah, this number agree with the calculation here. 38,187.67. Okay, so we use calculator, did these 3 steps, okay, for the cost. Now let's look at the formula. The formula is here, the cost. The formula involved in step 2 is present value equal to PMT times 1 minus 1 plus I raised to power negative N over I. And for step 3, the formula is present value equal to future value times 1 plus I raised to power negative N. All right. And then you compare the money in with money out. You make decision. Okay. So this is this question. Okay. The net present value is positive. So the rate of return, we conclude the venture should be undertaken. So that concludes the net present value for session 2 of chapter 16. Take a break and then we'll go over last session, session 3 of chapter 16, rate of return. Okay. But first, are there any questions? Try to go back to the chat room. I'm going to stop recording.